Today's kit build is lubricated by See a Man About a Dog, Northern Brown Ale from Stone Angel Brewing in Winnipeg. They describe it as a malt-focused northern-style brown ale with nuttiness, biscuit, caramel, and an overall balanced taste. So since not knowing exactly what I was doing worked so well last week, let's just dig at random into the box of kits and pull out this one. Got a long, skinny circuit board in there, a whole bunch of LEDs along the top, and a bunch of chips and things. Okay, this could be interesting. Does it actually say what it is on it? Well, if it does, it doesn't do it in English. Okay. Does this help us at all? Doesn't help me. It uses USB, it uses LED. There's 12 of those and 8 of those. Okay. Yeah, no, that doesn't help me much. Can we see what are the ICs on here? LM358, they are op amps. But there's what it looks like when it's done. Fine, we got a bunch of ICs and some sockets. There's a bunch of LEDs in there. And a bunch more LEDs outside of the bag. Several resistors of that ilk. Okay, oh, what are you? You are a microphone. Some capacitors. Sure. Shouldn't be that difficult to put together. Do we have... Yeah, we have the values on the board. Okay. Whole bunch of 510 ohm resistors. Got to assume those are the series current limiting resistors for the LEDs. And then we got all these op amps up along here. A couple of bigger electrolytic capacitors there. So I'm going to guess that it's either like a VU meter kind of thing, or it is a frequency selective kind of spectrum sort of display. Just based on what I'm seeing, the microphone really gives me the biggest clue that it's obviously audio based, and I can't think of anything else that's going to be audio based that's going to have a whole row of LEDs. Do you remember this thing from when it came in the mailbag? I'm pretty sure that's what it is, but I'm, again, only pretty sure. We'll have to just build it and see what it is. Like I said, it worked out okay last week doing that approach, so why not try again? So based on last week's kit build, I am going to give this board a little bit of a cleaning with alcohol, just in case there is some tarnish on there. Although this does look like a little bit better quality board. The pads are already tinned, so that should aid in soldering a whole bunch. And if it doesn't, well, maybe this will give us an extra fighting chance, just cleaning off any tarnish or oxidization. Hopefully, anyway. Another question that came up last week is somebody wondering if I was using leaded or lead-free solder. I am using MG Chemical brand, 0.032 inch diameter, aka 22 gauge. It has 2.2% flux in it, and it is in fact a tin lead solder, traditional 60/40. Before we get started, I'm just going to quickly go through and measure all of these gang together resistors and label them so that I can put it together quicker, easier. Those are 10K. These guys are all 500 ohms, which I guess I should have known. Actually, they'll be the 510s that are in there. Okay, I'm just going to do that for the rest of them just to help me a little bit and keep me moving along quicker as I'm building here. And with that done, we can proceed. This lone resistor here is a 2K. This is going to take a bit of effort trying to find all of these, although I've spotted Mr. 2K already over there. And I don't know how many of these I'll put in at once, just because I don't want to get the whole forest of component leads on the back that you always get. These two here are a pair of 1Ks, so I'll try and find them. 10K there, there's a 1K there. I prefer it when the component values are marked on the board, especially when the documentation is in Chinese and you can't actually figure it out. I mean, I suppose I could use a translation app, but this works, and why not do it this way? So where is the other 1K resistor? There's a 1 meg. It's a 100. I didn't find any... Uh-oh. I didn't find any 1 megs in my collection of parts here. Yeah, that is a 1K. And what's this guy? Oh, that is actually a 1 meg. Oops. Okay, well, I'm glad I'm second guessing myself already. Now, where did I find that 1 meg? Well, there it is. Wow. The odds of failure are already starting to climb. I think I saw a string of hundreds up there, so I will throw them in. And here's another suggestion that somebody mentioned in the comments of last week's video. Chop the leads off here so you don't get any tape goop into the holes. I've only ever had trouble with that on really, really old components, but it does make a certain amount of sense, so might as well give it a shot, I guess. And there's a handful of components in there, so let's get them soldered. Oh yeah, that is so much easier than that board I was messing with last week. So much nicer. I think being a double-sided board with plated through holes and pre-tinned pads is the biggest thing that is making this board work so much nicer than the last one. So now it's just a matter of finding all the resistors and putting them on. And as I've mentioned before, it's always nice to start with the lowest physical profile components so they don't get in the way of other things, and also the components that are least likely to get damaged from future soldering attempts on the board. And that is almost always the resistors, followed by the ceramic capacitors. Connectors fall into that category of hard to damage, but they're often large, cumbersome, and get in the way of future soldering, so I tend to leave those until much later in the process. Since that's only a couple and they're so far apart, I think I can get a few more legs in there without causing myself trouble. Like these 5K resistors. There's 5.1K there, 5.1K there, and where is the third one? I'll put those two in and then I'll hunt around, I guess. The more parts you get in, the less places there are to look for the other ones. Kind of wish this kit came with a schematic so that we could at least try and figure out how this thing works without having to reverse engineer it, but so it goes. So if I'm correct, I've just got all these 510 ohm resistors to go in, and there should be a dozen of them. 2, 4, 5, 6, 7, 8, 9, 10, 11. Okay, well, maybe there's an extra one, maybe I miscounted. Whatever. Let's get at her. I'm not going to make you suffer through watching all that repetition, though. I'm going to come back after I've put all these guys in. One moment, please. That is all the 510 ohm resistors, or at least all the ones I could find positions for. I've still got one left over. I think I'll just keep that over there, and that should be all of the resistors. Strangely, there are way more LEDs. There's 21 LEDs. At least there's no D2 to D21, so there's not 21, there's 20 LEDs. Now I'm confused about these resistors, unless they're paired or something. Although maybe they are, because it looks like each resistor goes to two different diodes, to the hot side of two different diodes. Yeah. Okay. So maybe that does explain why there's only 10 resistors. And I had 11 in the kit, so maybe there is only 10 needed. Regardless, let us continue on to the next least likely to be damaged components, that being the ceramic capacitors. And there are 2 of them. Each have a different value. Okay. I'm going to guess that this guy is a bypass cap because that's usually what those 104, what is that? 10 nano, I think. There's one of the capacitors goes there. Where is my other ceramic capacitor? I don't see that. Okay. The one thing that this is good for, I guess, is looking up the part numbers. Ah, there's a C1 and a C3, which are both 104s. Maybe that is a 104 just misprinted. They are C1 and C3. So that would put one of them right there. And where is the other one? Does anybody see a capacitor outline on there that'll fit a small ceramic capacitor? Yeah, me neither. Right. Set that aside with a spare resistor for now. Well, let's reach into our pile of parts back here and grab some diodes. We have 1 rectifier diode and 2 smaller signal diodes. That is a 5819, and it's labeled over there. The first of the components that matters which direction you put it in. Band is on this side, and it's marked on the top there, so we'll drop him in. Where is he coming from? It is coming from the power input. Chug, chug, chug. So that is going to be just a polarity protection diode. And there's these 2 smaller signal diodes. I saw one of them right beside it. Bend him up, and again the band is on this side here. It goes on the bottom on the board. This is one of those things that if you get overconfident, you get going too fast, you can mess up easily. And best case scenario, your circuit just doesn't work. Worst case, you could be shunting current in a direction that's not intended to and cause all kinds of grief. The other one goes down here, band towards that side, right. Okay, I can't really tell what it's doing. That's one thing. Double-sided boards are a bit of a bear to trace circuits on, especially if you're just doing it on the fly. If you do it like Big Clive does, take a picture, draw it out, take the time, then it's not too horrendous as long as, the traces aren't disappearing under components and you can't actually follow them. Then it gets to be a challenge. But I could have, I suppose, taken the time on this board to trace everything out and figure it out, but I think I'm just going to use a bit more empirical method of figuring out what this circuit does. Although like I said, I'm 90% confident that it's either a level meter or a spectrum analyzer kind of thing for the LEDs. And the more I think about it, each stage doesn't have any frequency selective components in it. It's only resistors and amplification. So this is most likely going to be a VU meter or a level meter or volume meter. So let's carry on that assumption and install these electrolytic capacitors. There's 2 of them. One's 100 microfarad, one's 4.7 microfarad. That one's 100 microfarad. Okay, that goes over here. And it gets to lie down flat on the board. A different way of marking the polarity on these guys than there is in the diodes. You've got the negative stripe on this side of the can, and sometimes they mark them as positive or negative, but in this case they've got a negative stripe marked on the board. So we'll lay this guy in that away. 4.7 microfarad next to it. There's a 10. Save him for later. You're 4.7. Yes, you are. And again, look for the band. This one's going to take a little bit more heat because it's got a big ground plane on it, but there we go. Something else that's nice on this board that the other one didn't have, it's got solder mask on it, making it much, much harder to short between adjacent tracks. Now, normally I'd want to put the connectors on any time now, but I think I'm going to save this connector till last because it's kind of buried there. What do we have here? We have a potentiometer. It's not really polarized, and it doesn't really matter which way it goes on. However, I notice on the board, it has a little indicator for the screw terminal at that end. So I shall put it on in that orientation. Electrically, it doesn't matter. That's just cosmetics as much as anything, I think. But we'll go with it nonetheless. All right, I think now my options for soldering are down to the IC sockets and the LEDs. Oh, and I guess that little microphone module, I suppose I could put him in there now too, couldn't I? I see it has a positive label on that side, which makes sense, I guess. It is an electret microphone, which is essentially a little capacitor that needs a charge in it, but there's no obvious marking on here which is positive and which is negative. However, if we get our meter in continuity beep beep mode, one of them is going to be connected to the shell, which is that one. So that one I will call negative, which I think makes sense, which means we go in this way right here. So, as I was saying, pretty much the only thing left is the IC sockets and the LEDs. I think I'm going to put the IC sockets in first, just because if I put the LEDs in first, I think it will be very difficult mechanically to get at these sockets. Because when I put the socket on there, I'm going to lose my pin 1 marking, which is that little dot there. We also have the notch marked on the silk screen at that end, and we have a little notch on the end of the socket. So I'm going to put them in matching orientation just so that we get the chips in properly later. And I am going to use just a little blob of blue tack just to hold those guys in place while I'm soldering, because there isn't enough lead on them for me to bend the leads over to hold them in place. Standard practice, or at least my standard practice for doing ICs and multi-pin components, is to tack down the corners first, starting with 2 diagonally opposite corners, then the other ones. Right now I'm just heating up and reflowing the pads and pushing with my finger to make sure everything is stuck down properly. And it is. So now I will finish up with the middle pads. And because these are cheap sockets, I am going to dance around a little bit just to spread the heat so that I don't actually melt the socket. It's not necessary to do, but it's just a good habit to get into, I think, just to protect whatever you're soldering. Now, let's repeat that a bunch more times. That is the IC sockets in. Now, I think I'm going to tackle putting in the LEDs. I think I am going to just go quickly through and test them all before I put them in, so I don't get burned like last time. Because last time, people might be wondering what happened to that single LED in the kit. And the problem seems to have been that just the LED was bad. It wasn't so much that I put it in backwards, which was my initial thought, or that I soldered it poorly. It's just that when I pulled it out and tested it, it simply didn't work. So I'm going to test each one of these before I put them in. It's a quick check. It's not that intensive. It doesn't waste that much time. And you may notice that I'm putting them in every second spot initially. That is simply to give me room to solder. So I'll put in every second one. Then I'll solder them in and trim the leads. Then I'll come back and put the rest of them in, giving myself room to work. This is supposed to be fun. There's no point in creating more problems for yourself while you're doing it. Right? Right. So as I was testing these LEDs, one of my kids came in just to see what I was up to and asked me, how come some of the LEDs are red and some of them are green? And I said, huh? And I reminded them that I'm colorblind, so they said, yep, some of them are green and some of them are red. So it turns out all the ones that I've got in here so far are the red ones, and they were packaged outside of the bag. The green ones were all packaged inside the bag that had the ICs in it. So now I have to go through and resort them and revise my plan here. So I'm thinking that probably if this is a volume meter, then the top half are going to be red and the bottom half are going to be green. That's my thought. So I'm going to take these red ones and move them up to the top. I think that's a red one. And start from there. So that kind of throws a little wrench into my plan here, but we'll persevere. And there is the last of the LEDs, hopefully all in the right positions. And I think that is all the soldering except for the USB power connector on this end. This is not exactly ideal, but I guess it will do. I suppose I could grab a different board holder than this one, but this will work. Oh. This is specifically a power connector, so it doesn't have all the data connections. It only has the 2 power pins. Well, there we go. Those other 2 larger ones are just mechanical. They're not electrical. I think that went in more or less straight. Cool. So now I think I will clean up a lot of these short circuits. At least just get them out of the way, and then I can demanguate all these ICs and plop them into their sockets. That is a proper mess. Why does nobody ship these things in, I don't know, a foam block, or even the tubes that they come from the factory in, or something like that? Anyway, I will spend a little bit of time here. It's not that difficult, it's just tedious. And I could use my IC pin straightener that I was given, but these things are in such mangled condition that I think the pliers are probably going to be faster. Okay, now that those are hopefully straightened, let's put them in. The notch side is at this side here. You can see that there's the matching notch on the IC itself. So I'll just hopefully ease those down into the socket, making sure that all 8 pins line up. Push it home. Yeah, it looks like all the pins went where they're supposed to go. None of them doubled under. Cool, so just repeat that 5 more times. As I mentioned earlier, it would have been nice to have a schematic at the very least to work from just for troubleshooting. But it's a simple enough circuit that if I have to go to the effort of chasing it down for troubleshooting purposes, I will. I'm crossing my fingers that I haven't made so many mistakes that I'll have to do a lot of troubleshooting. Overconfidence? Maybe. We shall see very shortly. As I'm looking around, I've noticed that I made a mistake. I'm missing capacitor C3, which is going to be this other ceramic capacitor that I couldn't find the spot for earlier. Right, well that's an obvious dumb mistake, and also one that's easily corrected. Let's hope that's all that's wrong with it. That would be easy. Let's try it again. Oh, there we go. Oh, hey, that's doing exactly what I thought it would do. Very cool, except for that one LED right there. What is your problem? Did I put you in backwards? Okay, so if I adjust the sensitivity this way, 1, 2, 3, 4. Hello, 1, 2, 3, 4. Let's go all the way. 1, 2, 3, 4. Okay, now we'll go back the other way. 1, 2, 3, 4. Sure, that works well. Okay. Can I get it so that there's only 1 or 2 comes on unless I really scream? Cool. And I'm guessing if I go the other direction all the way, it will respond to the most sensitive of sounds. It is responding while I'm screwing around with it though. Hello, 1, 2. 1, 2. 1, 2, 3, 4. Right. Do we want to figure out what's wrong with this LED right in the middle? I'm going to guess that it just needs to be reflowed solder, I hope. Or maybe its current limiting resistor is not right. Something like that. I don't know. We'll find out in a second here. So this is kind of janky, but it should work. Yeah, okay, that does that pair. And this is the one that we're interested in here. Oh, okay. So its partner lights up, but it doesn't. Interesting. Why is that? I'm assuming that D11 is bad. But I'm pretty confident that I tested these guys all as I was putting them in. Does this work? Did I blow up my... No, it works. It's a green LED and it works. Ah. So here's what I think is the problem. I've got a green LED and a red LED in parallel, and green LEDs and red LEDs have a slightly different forward voltage. Now, this green LED still works, 2.325 volts, but the red LED that's in parallel with it is 1.75 volts, so it lights first and it clamps the voltage. So my options are to put 2 green LEDs in parallel by removing that red one and using a couple of these extra green ones that came with the kit. Well, they're not extras anymore because this is what they're for. Oh, or to put another red LED in, but it won't match. So I think what I'm going to do is pull that red LED out and drop in 2 greens, and then we should work. A bit more desoldering here, and we'll come back in a second. Now let's see, where is my power lead? And here we go. Plug it in the right way up. Good. Zoom out just a little bit so you can see them. Hello, 1, 2. There we go. That's more better. Where are we? There we go. Put the red at the top. Well, it actually works. That's pretty cool. I've never had one of these. I mean, obviously it's not super calibrated, but just as a sort of a decorative music sensitive light, that's pretty cool. Now this is probably one of the more primitive versions of this kind of a circuit that you can get. Well, I hope you found that interesting, entertaining, amusing, something, at least not a waste of your time. I had fun building that, as I always do, regardless of whether I make mistakes or not. And the mistakes that I made this time were fairly simple and straightforward to correct from. So there we go. Yeah, thanks for watching. I appreciate it as always. Questions and comments down below. I'll talk to you later.